Okay, today's work we're going to be looking at the differentiation of inverse trigonometric functions. So what we're going to look at here is we're going to look at y is equal to the inverse sine of x over a. So the first thing is we actually cannot do the differentiation of inverse sine functions. So what we are going to do is we're going to do a little trick. We're going to do sine on both sides. So if I do the sine on the left, I'm going to get sine of y. And if I do the sine on the right, I'm just going to end up with x over a. I'm then going to multiply both sides by a, and I'm going to get a sine y is equal to x. So therefore I'm now going to write down here that x is equal to a sine y. Now I know I can differentiate sine function. We did this before the holidays. We differentiate sine, we get cos. If we differentiate cos, we get minus sine. And if we differentiate minus sine, we get minus cos. And when we're moving down the line, we are differentiating, and you were told to learn that. Now, you need to listen very carefully at the next bit. I am going to differentiate the x variable on the left with respect to the y variable on the right. So the notation is dx dy. And when I differentiate sine, I get cos. So it's now going to be a cos y. And now I'm going to flip the fraction upside down, because what we really wanted to do at the very beginning is we wanted to work out dy dx. So what I'm going to do now is I'm going to turn the fraction on the notational fraction on the left upside down and get dy over dx, and on the right hand side I'm going to write 1 over a cos y. And in order to finish off this problem, I have now got to work out what cos y is equal to. So in order to do that, I am going to go back to where I had sine y was equal to x over a. So I had sine y was equal to x over a. Now there's two ways I can do this. The first way of doing it is I can remember from the formula book that cos squared plus sine squared is equal to 1. So therefore I can put in here that cos squared y plus sine squared y is equal to 1. So I've now got cos squared y plus x over a all squared is equal to 1. So cos squared y is equal to 1 minus x squared over a squared. Now I'm going to get rid of the fraction by multiplying everything by a squared. So I'm going to have a squared cos squared y is equal to a squared minus a squared on x squared over a squared, and that's going to cancel. And then from that I'm going to have a squared cos squared y is equal to a squared minus x squared. and then cos squared y, dividing both sides by the a squared is going to give me this, and therefore cos y is going to be equal to, well, if I square root the top, I'm going to get the square root of a squared minus x squared. And if I square root the bottom, I'm going to get a. I'm now going to substitute this into this line here. So I've now got dy dx is equal to 1 over a on the square root of a squared minus x squared all over a. The a's are going to cancel, and then we're going to end up with dy dx is equal to 1 over the square root of a squared minus x squared. Which is the formula written up in the table above. Okay, so that's deriving the formula. We won't derive the other two formulas. I may set that as a homework for you to do later. But what we're going to see now is the using the formula in order to solve a problem rather than going through the system of mathematics that we just did. So we're looking at first is we're going to look at y is equal to the sine inverse of x, which we immediately write as x over 1 and put that in brackets. We're going to be using the formula over here on the right-hand side. So we've got, and in that formula, we've got y is equal to sine inverse of x over a. And that implies that dy dx is going to equal to 1 over the square root of a squared minus x squared. So what you do is you go to the formula book, you've got your question written down, you write it down, you make sure that you've got it written as a fraction, the variable has to be on top, and numerical has to be on the bottom. You then compare it to your formula. The x in the formula is going to equal, in this case, the x here. So that's really simple. So what I'm going to do now is I'm going to write here my x in the formula is going to equal the x in the question. And what I'm going to do now is I'm going to differentiate the x in inverted commas with respect to the x on the other side and get a value of 1. And this is called the multiplying factor. And now what we're going to do is we're going to apply the formula. The formula says that when we differentiate the y with respect to x, that the formula says we have a 1 on top. So therefore, I put a 1 on top. Whoops, I also forgot to write in here, what's the value of a? Well, the value of a is equal to 1. I'm going to write that now. So then I go to the formula again. I see it's a square root symbol, and they're asking me what the value of a is. And I've already recorded it here. The value of a is equal to 1. So we've got 1 to be squared. And then we've got a minus sign from the formula. And what's our value of x in the formula? Our value of x in the formula in reality is also equal to x, which is then squared. And what we're doing here is we're using a version of the chain rule, because whatever the multiplying factor is, we multiply by it. So we end up with dy over dx is equal to, well, 1 on 1 is 1 over the square root of 1 to be squared, which is 1, minus x to be squared, which is x squared. And that's the end of that problem. And we're going to do the same again. It's going to be sine function each time so that we can get it into our heads. So we've got y is equal to the inverse sine of x plus 2. Over here, we're going to copy out the formula from the formula book, and we're going to write down, well, y is equal to the inverse sine of x over a. And we also know that the dy dx version is going to equal 1 over the square root of a squared minus x squared. Now back to here. What's my x in the formula? The x in the formula is equal to x plus 2. Comma. The a is always a number. Now, if there is no fraction, then we know that the bottom of the fraction is in actual fact equal to 1. So we can drop that in there now. And therefore we can now state that a is equal to 1. What do we do with this x? So we've got the x written down, we've got the a is equal written down. And then what you've got to remember is you've got to work out the multiplying factor. And the multiplying factor is the differential of the inverted comma x with respect to x. And when we differentiate x, number in front of x is technically a 1, so we end up with 1. We differentiate to plus 2, the answer is 0. So therefore our multiplying factor is equal to 1. So what we've got to do now is we've got to apply this formula here. So we've got dy dx is equal to, and the formula says on top there is a 1, so put a 1. And then it's a square root symbol, and then it's open bracket, and inside the first open bracket is the value of a, and the value of a from our working out is 1, which we're then going to square, plus, and then inside our second bracket is our value of x. Well, we already know that our value of x for this formula is going to be replaced by x plus 2. So we put x plus 2, and of course that is to be squared. And technically, this is a perfectly acceptable answer. Dy dx is equal to 1 over the square root of 1 plus x plus 2 to be squared. Perfectly acceptable. However, I suspect the answers in your books will probably go on to expand it out and tidy it up. So if we expand out x plus 2 on x plus 2, we're going to get x on x is x squared, x on 2 is 2x, plus 2 on x is 2x, plus 2 on 2 is 4. So we're going to get x squared plus 4x plus 4. So we're going to get plus x squared plus 4x plus 4. And then one more line of working out. dy dx is going to be equal to 1 over the square root of x to be squared plus 4x plus 5. That's the end of the second example. Moving on. It's all going to be very repetitive. So now we've got the last example, which is y equals the inverse sine of 3x minus 2. And again, we have to be mindful that the correct format, it must be over a number. So what we're going to do now is we're going to put that over the number 1. So it's now in the correct format. So we're going to be using the formula y is equal to the inverse sine of x over a. And when we finished interpreting what the x and the a are in that formula, we're going to apply it to the answer, which is dy dx is 1 over the square root of a squared minus x squared. So we're doing a comparison. So the x in the formula, which I'm going to use inverted commas to highlight, is equal to or compares directly with the 3x minus 2 in the question. The a in the formula compares directly to the number 1. That's the first two bits done. Then what we do is we come back to the variable and we differentiate both sides. We differentiate the left, which is x inverted commas, with respect to the variable x on the right hand side. When we differentiate 3x, we get 3. When we differentiate minus 2, we get 0. And this is, don't forget, the multiplying factor. So now we're going to apply this formula. So dy dx is equal to, and it says 1, so it's 1 over the square root of a squared, well, a is equal to 1, so it's going to be 1 squared. The formula says minus, so you put a minus there, open bracket. And what's the x equal to? Well, the x part of the formula is equal to 3x minus 2. Or to be squared. And this is the bit you've got to now remember. There is a multiplying factor. And the multiplying factor is we multiply the top by 3. And this is an application of the chain rule, which we're going to see throughout the next few sections of work. What grade is this? I would say I'd put it up there at H4, H3, H2. If you can get it right, even better. Now, the answer above can be simplified to 1 minus open bracket 3x minus 2 all squared. And as far as I'm concerned, I would leave it like that. But again, your book doesn't do that, unfortunately. I think moving on to the next stage wouldn't necessarily yield any more marks. I will show working out for the next stage anyway, just so as you can see what's going on. So you've got 3x minus 2 to be squared, so it's 3x minus 2 on 3x minus 2. We're now going to multiply that out, 3 3s, so it's 9x to be squared, minus 6x, minus 6x, plus 4. And then we're going to tidy that up. It's going to be 9x squared minus 12x plus 4. And then we're going to do 1 minus it. So 1 minus open bracket 3x minus 2 all squared is the same as 1 minus everything that we've just worked out. So that becomes 1 minus 9x squared plus 12x minus 4. So that becomes minus 9x squared plus 12x minus 3. And the answer will be 3 over the square root of minus 9x squared plus 12x minus 3. And that's the end of that particular problem. Okay, let's go on to do the final problem. We've got working out the differential of this problem. Now, this is slightly harder and a bit more thought involved. So y is equal to the sine inverse of 1 over x squared. Now the problem is that when we look at the formula for the inverse sine formula is the x is always on top and the constant is always on the bottom. And when we apply that formula, the dy dx will be equal to 1 over the square root of a squared minus x squared. So the problem is that x is in the wrong place. And so we know from previous work in calculus on differentiation that if the x or x squared or x cubed is in the wrong place, we can bring it to the top. And when we bring it to the top, then the power becomes a negative. Now, when there's apparently no number on the bottom, same as before, same as the very first example today, we put a 1 on the bottom because that's technically what is there. The x in the formula compares directly with the x that's here. So therefore the x in the formula is equal to x minus 2. The a is clearly equal to the 1. We're now going to differentiate this x with respect 2x to get the multiplying factor. When we differentiate x to the power of minus 2, we multiply by the power, and then we put the power down 1, so minus 2 becomes minus 3, and this has become our multiplying factor, which we multiply by at the very end. So we're now going to apply the formula, and dy dx is equal to, well, what's it say is on top? It says 1's on top. So there's 1. And then it's got the square root of a to be squared. So it's going to be 1 to be squared minus sign, open bracket. What's the value of x? Well, the value of x is x to the power of minus 2. And what are you doing to that value of x? According to the formula, you're squaring it. And at the very end, we then multiply by the multiplying factor, which is minus 2 on x to the power of minus 3. So what we need to do now is a little bit of tidying up. So we've got dy dx is going to equal to, didn't come out very well, did it? So we've got dy dx is equal to 1 on the square root. Well, 1 to be squared is 1 minus. Now, when you are squaring powers separated by brackets, sorry, let's say that again. When powers are separated by brackets, we're using the third law of indices where we multiply the powers together. So that's now equal to x to the power of minus 4. Now here we've got a minus 2. So minus 2 is on top. And that says x to the minus 3, which we can bring to the bottom and call it x to the power of plus 3. And then we can finish it off by saying dy dx is equal to 1 over the square root of 1 minus, now the x to the power of minus 4, the 1 can be left on top, and the x to the minus 4 can come underneath, the x to the power of 4. And then we're going to multiply the minus 2 over x cubed. And that is technically the answer. There's one more line of tidying up you could do. You could do minus 2 on 1 on top to get minus 2 on top. And then you could put the x cubed at the very front before the square root symbol, and then just do 1 minus 1 over x to the power of 4. Now technically that line here is correct, and you should get, unless they specifically ask you to simplify it, full marks for that particular bit there. There's other ways of simplifying it as well, but I just think it's going a little bit over the top, to be honest. You can just keep going on forever. I'm going to do one more example. This time I'm going to switch it up a little bit. I'm going to do y is equal to the inverse tan of x to be cubed, close bracket. I'm then going to write down what they've given us in the formula book. Y is equal to the inverse tan of x over a. So what does the x in the formula equal? Well, the x in the formula is equal to x cubed. And what does the a in the formula equal? Well, if there's no number at the bottom, we know the number is 1. We also know for the x bit, we differentiate both sides to get the multiplying factor. So the multiplying factor is 3x squared. We are now going to apply the formula, and I'm going to write the formula here. Might be a better place to actually write it. I'm going to write it in blue so that it stick out a small bit. So we've got dy dx is equal to a over a squared plus x squared. So now, what do we know about the value of a? Well, we know that the value of a is equal to 1. So that's 1 on top. We know the value of a is equal to 1, and 1 squared is what we have there. Plus, open bracket, we're now looking for the value of x. Well, the value of x is x cubed. And what's happening with that x cubed, according to the formula? It's been squared. And then there's a multiplying factor. There's the multiplying factor. Forgot to write in multiplying factor. And the multiplying factor is 3x squared. So dy dx is equal to 3x squared all over 1 plus. Now, don't forget laws of indices, powers separated by brackets, 2 3s are 6. It's going to be x to the power of 6. And that's the end of the problem.